My name is Daniel Apt with Olanio, and I am project lead for the SMC Clean project. SMC Clean Module 3.2 covers LID and GSI construction, which is Chapter 2 in the SMC Clean LID Construction, Inspection, Maintenance, and Monitoring Guidance Manual. An overview of LID and GSI construction. Construction guidance primary purpose is to ensure that LID and GSI measures are constructed per the design plans and to ensure their proper function and performance. Construction guidance is critical, as although LID and GSI has been around for a while now, many LID and GSI systems are not constructed adequately or consistently with the approved design plans. Critical to construction guidance is that minor modifications to the design or small elevation changes in LID and GSI measure elements can have a significant effect on performance and function. Contractors and subcontractors may not be familiar with LID and GSI systems and implement design or material modifications that affect function and performance. Construction inspections are also a critical element, and they are covered in Module 3.3. One of the critical elements to construction guidance for LID and GSI systems is site management, planning, and scheduling. The development of site management goals is an essential step in the planning of an LID or GSI site. The site management goals and the construction sequencing schedule should be developed prior to the pre-construction coordination meetings with a contractor and subcontractor. Site management goals should be developed specific to each site, but should include protection of existing vegetation and trees, protection of LID and GSI system locations from construction activities and off-site stormwater runoff. This is a critical element to ensuring the future functionality of these systems. Critical to integrating into sites is an effective combination of erosion and sediment controls. Also, identification and protection of existing utilities, and protection of LID and GSI construction materials to make sure that they are not contaminated or out in exposure for long periods of time. And finally, protection of LID and GSI vegetation until it is established, and any other specific issues to the site. Another critical element of site management planning and scheduling is construction sequencing and scheduling. So this will be different based on whether the LID GSI site is a retrofit or new construction. There are very specific constraints in a retrofit situation that are not the same as new construction. Construction sequencing and scheduling is a critical component for the effective implementation of properly performing an LID GSI structural measures. For new developments, construction sequencing is essential. LID and GSI features should be installed at the end of construction if possible. This avoids the potential for construction materials to contaminate a newly constructed LID and GSI feature. If it's not possible to construct these at the end of construction, measures should be implemented to protect the LID and GSI measure locations. Construction scheduling must consider also the specialized materials and their associated lead times in constructing LID and GSI systems. This includes an example of, for a bioretention system, is bioretention soil mix, your bioretention stone aggregate, plants and mulch, and potentially impermeable liners, depending upon where these systems are being located. Another element of site management planning and scheduling is the essential element of pre-construction coordination. Coordination prior to commencing construction of LID GSI measures is critical to ensure proper installation and protection of LID and GSI BMPs during constructions. Protocols for communication and submitting and answering requests for information should be discussed during the pre-construction coordination meeting. Pre-construction coordination meetings should cover in general all the information in this training and in the LID construction chapter of the SMC Clean CIMM manual. The following subjects should be covered in detail: safety and site management, construction documents for the LID measures, essentially the design plans and what's expected in implementing those design plans, proper construction sequencing and the schedule for the project, critical path items, checkpoints, and verification, the LID construction materials and the process for evaluation and approval of those materials and any substitutions, and communication protocols. The contractor, subcontractors, and the designer should all be present at the pre-construction coordination meeting. Another element of site management planning and scheduling are the construction documents themselves. The construction documents include the design plans that identify what to build and the specifications that identify how to build it. Construction documents must include a title page that includes the project name, location, and designer information, a plan view sheet providing a geographical reference looking down at the project site, a section view, also known as cross sections, of each LID GSI feature, which provide an overall view of all critical elements and detailed views of the LID GSI measure as seen if viewed across the critical elements. Standard details provide a detailed view of critical elements such as a LID GSI measure. A pertinent detail such as a curb cut or overflow riser should also be included. And then specifications, which provide written detailed information on materials used on a construction project as well as the proper technique required for installation and construction. Those are the critical elements that must be included. Construction documents should also consider including the plan view sheet, including a legend, topo, contours, locations of existing features, utilities, vegetation, and property lines, and in some cases, erosion and sediment controls. They should also include the longitudinal profiles and the longitudinal section, which pertains to a section along the long axis of a structure. The next section is focused on safety in and around LID and GSI. Safety is of concern in the construction of LID GSI measures, as many elements of construction of these measures have hazards associated with them. Safety should be discussed as part of the pre-construction coordination meeting. And safety protocols should include plans to ensure that the site is protected and secured with effective perimeter controls. There should be a traffic safety plan that includes vehicle, bicycle, and pedestrian plans. There should also be protocols directing staff to call dig alert before digging to locate utilities. Existing utility protection and marking. There should be identification of safety procedures for overhead power lines. There should be confined space identification, protocols for all workers to wear the PPE, schedules for frequent safety meetings to inform workers and coordinate upcoming construction activities, proper implementation of erosion and sediment controls and dust controls, and protocols that call for the use of trench boxes or shoring for trenches over 4 feet deep. And then instructions to divert stormwater away from trenches around the site. The next element is LID and GSI materials. The use of specified materials in the construction of LID and GSI measures is essential to LID and GSI performance and durability. Guidance associated with these materials includes source material before construction begins to ensure that the materials specified in the design plans are actually available. Please note that there may be longer lead times for these types of materials. Any proposed changes to the specified materials should be coordinated with the designer. And the materials and a process for substitution of materials should be discussed in the pre-construction meeting. Materials used for construction and LID facilities should be clean, such as aggregate should be washed. And all materials should be inspected prior to the installation of the LID and GSI system. This is critical, otherwise we'll see spiking in pollutant export from these systems. All GSI materials should be protected at the construction site prior to installation. Protection includes covering and perimeter control around stockpiles of LID and GSI construction materials. LID and GSI materials should not be delivered to the site until just before their construction. This will reduce the incidence of contamination of the system materials. And then also avoid placing LID and construction materials in concentrated flow paths and or near catch basins. Typical LID and GSI materials include aggregate, bioretention soil media, mulch, riprap, geotextile fabrics, liners, and waterproofing membranes. The next element is site layout, survey, and utility locations. This includes primarily associated with LID and retrofit projects and redevelopment sites. Usually utility location guidance is associated with these retrofit projects or redevelopment sites, and is not an issue associated with new development. One element is to verify how the proposed construction layout interacts with the existing infrastructure. Understanding if infrastructure needs to be, existing utilities need to be relocated or avoided, depending upon the type of utilities that are present. Methods to identify the locations of existing utilities include site as-built, record plans collected from utility providers, surveys providing the location of utility surface indications, potholing to determine locations and depths of known critical utility lines, and then also the use of ground penetrating radar. Overhead, surface, and underground utilities should be evaluated for conflicts with different phases of construction. And construction should not commence without a clear understanding of how utility conflicts are to be addressed. The next element is geotechnical investigations. Accurate geotechnical investigations to understand infiltration rates are critical to those LID and GSI measures relying upon infiltration. Geotechnical investigations to determine infiltration rates, substrate composition, depth to groundwater should be completed as part of the design phase of any LID and GSI feature. Confirmation of infiltration rates with testing once excavation of the GSI LID location is complete is a critical step to confirming that the infiltration rates are actually going to work for the design storm. Infiltration tests should be performed at the depth of the invert of the LID GSI system using an appropriate methodology by the approving jurisdiction. Common infiltration tests include double ring infiltrometer test, single ring infiltrometer test, and drill hole permeability test. Geotechnical engineers will integrate a factor of safety that should be applied to determine the design infiltration rate. The factor of safety is at the discretion of the engineer, the geotechnical engineer, or the local jurisdiction. And that's really based upon the underlying soil type and the expected sediment loading for that particular BMP. Essentially, what does the drainage area look like? The next element is existing vegetation and tree protection. Existing vegetation and trees provide hydrologic benefits by retaining stormwater discharge on site. Protecting existing vegetation and trees outside the disturbance area of the project is critical, especially because vegetation takes a long time to regrow. Trees are specifically susceptible to damage from soil compaction near the root zone that may be caused by construction equipment. Trees should be taped off at the drip line to warn on-site workers to avoid construction equipment or storing equipment or materials too near to the trees. Tree branches may also be damaged by large overhead equipment such as excavators, and construction stormwater should be routed away from existing vegetation with gravel bags to avoid impacts to vegetation. Just as critical as protecting existing vegetation is protecting the area where your GSI and LID BMP will be placed. As the surrounding site is constructed, it is critical to protect the on-site locations where these measures will be implemented. These areas should be protected from compaction, sedimentation, and pollutants. The area should be taped off and surrounded with gravel bags to prevent sedimentation and deposition of other pollutants. Construction stormwater should be conveyed around these areas if possible. Construction stormwater flows may carry fine sediment into the LID GSI area, which may reduce or eliminate the ability of these locations to infiltrate stormwater, which would negatively affect the overall LID approach for the site. Additionally, the weight of the water may result in compaction of the area, including the substrate, which would reduce or eliminate the infiltration capacity of the future LID and GSI system. Additionally, LID and GSI locations should only be excavated when they're ready for construction. If excavation is needed prior to that, a 6-inch layer of soil above the excavation depth should be left in its place. Excavation machinery should be located adjacent to and not inside the LID and GSI system. That equipment will cause compaction and reduce the infiltration rate of your LID and GSI systems. Location of the future LID and GSI measures should not be used as temporary sediment basins during construction. Even though many of these sites are in low spots, using them as sediment basins will affect the long-term infiltration and viability of these locations. Erosion and sediment controls are a critical component to LID and GSI construction sites. We need an effective combination of both erosion and sediment controls that are needed to protect the LID and GSI areas. Erosion BMPs are designed to keep sediment from being mobilized in their natural location, and sediment BMPs are designed to capture sediment from discharging off your construction site. The erosion and sediment control plan for the site should include specific protections for those future locations of LID and GSI measures. Specifically, the California Stormwater Quality Association Construction BMP Manual should be consulted for construction site stormwater management BMPs. We'll now get into a little bit on bioretention specifics for construction. Although used early in the development of bioretention systems, filter fabric should not be used in the invert of LID and GSI landscape features, as it may cause long-term clogging and system failure. Sediment migrates down to this layer and occludes the layer and prevents draining of these systems. Filter fabric should not be used in the invert. Make sure that the bioretention soil mix is used per the design specifications, and we do not want to see bioretention soil mixed on site using native soils. Bioretention soil mix should be mixed off-site at specific wholesalers or locations that sell this material. Compaction of the bioretention soil mix should adhere to the compaction procedures identified in the BSM specifications. There should also be a verification of the BSM elevations per the design plans. We want to ensure that the final grades are maintained upon completion of plant and mulch installation. And excess soil from the planting should be exported or reincorporated to meet the design contour. It's critical. We see a lot of systems where they put in too much BSM, and that reduces the capacity of the system. We also want to ensure that the bioretention plants adhere to the planting plan within the design submittal, and that the bioretention plantings themselves are protected until they are established to be able to handle the velocity of stormwater flows into that system. Additional bioretention specific guidance. One of the things is that we should use non-floating mulch such as aged compost or coconut fiber. Wood mulch will float and clog overflows. We also want to ensure that overflow risers are not at the elevation of the bioretention system. If we have this, we will have short circuiting, and we'll have a very expensive landscape planter. The overflow risers need to be raised to allow for ponding to happen, otherwise stormwater will discharge out the riser and not filtrate into the BSM. We also want to ensure that the structural capacity of bioretention systems acknowledges the adjacent land uses, whether they be streets or parking lots or other areas that have potential structural issues. Because bioretention soil is not compacted, the planter walls will require proper structural supports. So use continual footings or lateral bracing to maintain structural integrity. For side slope bioretention systems, maintaining a native soil base adjacent to the bioretention system can help maintain that structural support. For bioretention systems that are on a greater than 2% slope, check dams should be used to allow for ponding and prevent erosion within the systems. Check dams can be made of concrete, rock, or even steel. And then we also want to ensure that we have proper energy dissipation integrated into the bioretention systems at the inlets, so we don't have erosion that occurs in the system. Very simple concrete splash pads and copple are effective energy dissipators in systems.